Hello, everyone. I welcome you to my data analysis in SPSS series. Again, my name is Dr. Lohua Mahmoudin. Now, today, we are going to actually extend our analysis of logistic regression, performing logistic regression analysis in SPSS. So let's get to it. Now, if you had time to watch the first video on this section of performing logistic regression in SPSS, we actually use the same particular data, which involve diabetes and other variables, which include, we have age, gender, we have the BP of the patient, which is the blood pressure of the patient, whether or not the patient smoke, the physical activeness of the patient, the cholesterol level of the patient. So we actually perform a logistic regression by selecting only one of the variables as our covariate. So we perform a logistic regression by looking at the association of diabetes with what? With blood pressure. That was what we actually look at. And the blood pressure was categorized as hypertension, normal, and then hypotension, normal, and then hypertension. And based on it, we said the hypotension was used as our reference group. And hence, this gave us two indicators. This particular variable is coded as a dummy variable or as an indicator variable. Hence, in the end, it gave us a logistic regression which has two variables, which is normal blood pressure and then hypertension blood pressure. So, and that actually allows us to be able to assess this blood pressure impact on or diabetes by comparing it with the reference group, which was hypertension. Now, in this particular section, we are actually going to pick more than one variable to see how our results actually changes and how can these results be interpreted. So again, we are still using diabetes as our outcome variable, and we will want to assess the association of some of these risk factors on diabetes. So we go to analyze, and then we go to regression, and then we have binary regression because diabetes is a binary variable or outcome. That's whether or not the individual have diabetes. So we click on a binary logistic regression. And then we have, first of all, you have to bring in your dependent variable or target variable or the outcome variable. So our outcome variable is the history of diabetes. That's whether or not the individual have history of diabetes. And then now we want to select dependent variable. So let's assume we are interested in selecting age category as a one of our covariates or independent variable. Then we have gender as also one of our covariates. We also want to use the blood pressure as one of them, smoker as one of them, cholesterol level as one of them, physical activity as one of them, and then also obesity as one of them. So let's say these are variables we actually want to make use of. Now you can select all of them just by clicking on control and then clicking on each of the variable, and now you can select them at once. So having selected them, the next thing is for you to click on this categorical, and then with this categorical, we want to move all this variable into this box for SPSS to know that this variable is dealing with a categorical variable. So let's select all of them. So you can also click on shift and then the down arrow key to select all the variables, and then you then push them here. So now SPSS can notice it as a categorical variable or as an indicator variable. Then also within the, we have it as indicator variable here under the contrast, so you don't have to change it. And then our reference group, we still want to keep the first coded value as our reference group. So we keep it as it is. So now we go to continue. And then we also have the option So again, the option, by default, this is not checked, but we also want to see the confidence interval of the odd ratio. So to know the confidence interval of the odd ratio, you have to check it. And then we keep it as 95% confidence interval. We don't want to change it. And then also we would want to see our constant variable. So we leave it as it is to include the constant in our output. So we go to continue. And then now regarding the variable selection process, we would want to still keep it as what? Enter. But we have several variable selection process like the forward selection, the backward selection. But let's keep it as enter method. And now we go to OK. So now this becomes our output. So based on our output, the case processing summary, there is no any form of missing value, which is good for our analysis. And then we have our dependent variable, which is again diabetes, whether or not the individual is having history of diabetes. Then these are our covariates, how the covariates, so these are the reference group. For instance, 45 to 54 is the reference group for the age category. Hypertension is the reference group for the blood pressure. Male is the reference group for gender. No obesity is the reference group for obesity. Normal cholesterol is the reference group for the cholesterol. No physical activity or active. That's not physically active is the reference group for physically active. And then no smoker is the reference group for what? The smoker, the smoke variable. So if you also go downward, we have the classification table, which again, you can use it in assessing the specificity and then the sensitivity of your model in terms of its prediction. But we wouldn't also dive much into this. This particular table only gives us the constant. And then this table is giving us the significance for each of our covariates. This is what this table does. It's giving us the significance for each of our covariates. And this significance here also represents the what? The p-value. So in this table, we are not having the confidence intervals and other statistics we might want to look at. So now we go all the way down, and we also have the model summary, which is also using to look at how effective was your model by looking at this R square here. So now we are not interested in any of this at this time. Let us look at our entire model, which is the major information we might want to look at, which is the variable in the equation and how the variables were actually selected and the significance of each of these variables. So if you look at this column here, we have this column being the coefficients, and then we have the standard error of the coefficients, we have the wild test, we have the degree of freedom, we have the p-value again, which is measuring the level of, will be used in measuring the statistical significance of each of our independent variables or covariates. And then we have the odd ratio. So the odd ratios are given here, which is again, it's using to assess the impact of each of the covariates on our outcome variable, which is whether or not the individual is having diabetes. And then we have the confidence interval of our covariates. So we have the lower bound of the confidence interval, and then we have the upper bound of the confidence interval. So now, by looking at this, which variables would you say are statistically significant? Now remember, this represents our p-value. So given that there's our p-value, we can first of all, if you have a given covariance or independent variable that has more than one indicator, then what you should see is that SPSS also give you the bivariate significance between the outcome variable, in this case, diabetes, and then the independent variable or the covariance. So over here, we can see that age is statistically significant. So in terms of the bivariate, we can see that age is statistically significant. And then also we can see that blood pressure is also statistically significant if we have to compare it with an alpha equal 0.05. So, and then by looking at this, we also can look at what other variables are statistically significant. So let us select the statistically significant variable. So we have this age category was statistically significant. And then we have also this blood pressure was statistically significant, which is representing the hypertension group. The normal blood pressure was statistically significant. And then individuals with obesity is also said to be statistically significant. So these were statistically significant variables that were found. So let us look at this group of age. This category group of age is representing, let's see, this age group is representing, that's, I think, that's 65 to 74. So 65 to 74 individuals, 65 to 70 individuals who are aged 65 to 74 are said to be statistically significantly associated with what the risk of being diagnosed with diabetes. So now, having seen the statistically significant, now we can also look at the odd ratios. So these are the odd ratios of each of the statistically significant value. So these are the odd ratio. So the odd ratio of those individual age 65 to 74, they have an odd ratio of 1.40. So again, given this odd ratio, if you subtract 1 from this odd ratio, we are left with 0.4. By multiplying it by 100, that gives us 40%. So it means that those individuals who are aged 65 to 74 have 40% increased risk of being diagnosed with what? Diabetes, or have 40% increased odds or likelihood of being diagnosed with diabetes. Now, if you look at the statistical significant, the odd ratio for the normal blood pressure, it is less than 1. And then by being less than 1, it means if you subtract it from 1, that is going to give us, that's 2.64. So 2.64 means that's 0.264. So by having 0.264 after subtracting it from 1, then what it means is that if you multiply by 100, 0.264 by 100, that is going to give us 26.4%. It means individual with normal blood pressure have 26.4% decreased odds or likelihood of being diagnosed with what? Diabetes. Then if you look at the hypertension group, again, they have a very high odd ratio, which is greater than 1. So it means that there is a positive association between having hypertension and then diabetes. So what it means is that if you also have to subtract this number, if you subtract 2.877, if you subtract 1 from 2.877, then we are left with 1.877. So 1.877 times 100 means we have 187.7%. So what it means that individuals with hypertension have 187.7% increased likelihood or odds of being diagnosed with diabetes compared to the hypertension group. So then also finally, if you look at the obesity, obesity is also giving us this odd ratio. By subtracting 1 from this odd ratio, we are left with what? 0.627. If you multiply by 100, that gives us 62.7%. So in this case, since it's greater than 1, it means there's a positive association of those having of those who are obese with diabetes. So what it also means that there is 62.7% individuals who are obese have 62.7% increased odds or likelihood of being diagnosed with what? Diabetes. So I only interpreted the variables that were statistically significant and then their odd ratio. So you can also use the confidence intervals of these values to also assess their statistical significance. Now remember, always whenever you are interpreting, at the end you always have to make mention of compared with the reference group. For instance, if you take the obesity, which is having an odd ratio of 1.627, then it means that individuals have 62.7% increased odd or likelihood of being diagnosed with. That's individuals who are obese have 62.7% increased odd of being diagnosed with diabetes compared to individuals who are not obese. So always make sure you do such comparison. And then again, with the confidence interval, if the confidence interval include 1, it means that they are not statistically, that variable is not statistically significant. So for instance, this age variable is not statistically significant. This variable is not statistically significant. This variable, all these variables are not statistically significant because they include what? 1 in the interval. And those that are statistically significant do not include 1. So also this represents a multivariate logistic regression or multiple logistic regression, you may call it. And then this also allows you to be able to assess the association of risk factors to diabetes by always making comparison with a reference group. So I hope you enjoyed this section, and I hope you've come to understand how to actually analyze a logistic regression model. And then I hope to see you in the next series of this particular data analysis in SPSS series. So thank you very much for watching, and see you there. Bye-bye.